All right, so hi everyone, my name is John, and we're going to chat about unit testing with Databricks today. So let's jump in. What we're going to cover off today, firstly, we're going to discuss why tests in the first place. Once we build up a reason and motivation behind testing, then we're going to look at different kinds of testing we can do and where unit testing falls into the broad spectrum of different types of tests. Then we're going to learn how we can write unit tests for Databricks, and I'll do a demo as well for helping you write these things out. And lastly, we're going to look at how we can automate these unit tests with CI pipelines, and I'll do a demo as well using GitHub workflows. All right, let's jump in. So why do we even bother with unit testing? Let's take a look at an everyday ingestion pipeline that you might have in your organization. Okay, so from the far left here, you've got a data source. It can be a database, can be a file, can be an API, whatever it is. We ingest data from that source. We put that into quote unquote level one. Level one can be things like your bronze or your raw. Basically, I just call it level one because I don't want to mix up terminologies that you might use that I don't use, etc. So we just call it level one. Then we do something to it. We perhaps clean that data. We deaggregate the data. We normalize it. We transform it a little bit. Then that's our level two. And finally, level three is probably things like your transformations, your business level aggregates, your group buys, and things like that before it gets into the hands of the user in the report. So that's what you might be familiar with. In reality, though, it probably looks a little bit more like this, where you've got one data source, one table, for example. You might split the table. Think of it as like a JSON file. Maybe it has two little lists in that JSON file. So you want to actually split that out into different tables in your Databricks tables, for example. You then do some cleaning to it, it becomes 3 files, and then you do some transformation, it becomes 4 files, and finally when it gets to the report, it becomes 5 files. Yeah. So typical pattern you might observe, right? One thing leads to another, becomes very, very big. All right, then one fine day, your team makes some changes to your code. You change a stop procedure, or you change a transformation step somewhere, or a Spark transformation notebook somewhere, and then all of a sudden things start to break. So this person here on the far right says, "Yep, looks good. Numbers make sense to me. Same numbers as expecting. Nothing looks off." The other 4 people in your business are saying, "Hey, wait a second. Something's not right here. The numbers do not meet like our expectations. It's just completely off from what we normally see." So this here is a problem. You know, anywhere in the pipeline could have that problem. So we're not sure exactly which part of the pipeline broke the code, which part of the pipeline resulted in all these breaks. You know, it could be all the way up here, could be on level 2, level 3. And this is where, as data engineers, when you have problems like this is where you spend a lot of your time. You're not spending time to fix the problem necessarily. It's, you know, once you've identified the problem, it's actually quite quick to fix it. You're actually going to be spending a lot of your time trying to find where the problem is and trying to debug and look through the error logs and try to make sense of where the error actually happened. So this is a very common scenario to have. So I want to see if I can get a show of hands, or maybe drop in the chat if you have encountered a scenario like this. So just type yes, I have, or something like that if you have similar issues like this before. Anyone? Yeah, thanks, Rob. Yeah, David, thanks. Yeah, so really, really common issue to face. Actually, and to be honest, this is actually a good scenario. This is a scenario where you have people saying there's a problem and they're notifying your data engineers about it so they can go and fix the problem. Good scenario. What's the worst scenario than this is where people don't even know that the data is wrong and they went ahead and make decisions off the back of that data, right? So they assume that the report they're looking at is correct, and all of a sudden some numbers look skewed. They're like, "Oh, this is a great opportunity. This new investment here is super cheap. Let's invest $1 million into this product or something." That's the worst scenario that can happen, where no one knows that the data is wrong and they make ill-informed decisions on that data. So how do we prevent either scenarios from happening, where people are calling you at night saying there's a problem, or people making very, very bad decisions and off the back of bad data? So the solution, as is the theme for this talk, is testing. Okay. So testing. We have different forms of testing we'll cover, but what testing does is it tells us where in the pipeline is the failure. So for example, in unit testing, which we'll cover off shortly, when our code comes in, if a change happens, we make sure that that code coming through is not going to break anything in our pipeline. If it does, We get rate X, we know where the problem is, we go and fix that straight away. In fact, it won't even come into production because our unit test CI pipeline will prevent that code from coming into our main pipelines. Oh yeah, and David saying, yeah, oh, when it gets mailed to 100,000 customers for your reports, 100%, yeah. All right, so what kind of testings can we perform? So we'll start off on the far left and we'll gradually move to the right where it becomes more and more production ready. So unit testing is the smallest form of testing you can possibly do. What is unit testing? You probably heard of this before, and I know I'm repeating probably, but think of that box here as a function, right? This black box here accepts some inputs. Say this circle here comes into the black box and out comes a triangle. Now, what we're trying to test here is the expectation, is the output what we expect, yes or no, green or red? That is unit testing. We're testing individual functions. What might we use for unit testing? There are a whole bunch of frameworks we can use. I'm going to assume here you're familiar with Python. You maybe write your pipelines in PySpark, in Databricks. So PyTest is a very, very popular framework to use for unit testing. And how might you trigger your pipeline? You can trigger that through a CI pipeline, or you can run it manually as well, which I'll explain later. The next level up from unit testing is integration testing. And that's where you're actually cobbling up some of these functions together and possibly even putting them into a pipeline orchestrator like Airflow or Data Factory or whatever orchestrator you like to use. And what we're going to test here is at each step of the orchestration pipeline, for example, level 1 to level 2 to level 3, or bronze to silver to gold, is the output what we expect? So when we ingest the bronze stuff, let's check the output. Does it match our expectations? Yes or no? Okay, matches, great. Let's move on to silver. Does it match our expectations? Yes or no? Great. Let's go to gold. Does it match expectations? If it does, then we can deploy that stuff. What might we use to test that? Again, PyTest is a very popular framework to test these sorts of things. And again, it can be triggered through a CI pipeline. But these are basically code changes. The first two, unit testing, integration testing, we're testing code changes. Now let's get on to the last type of testing, which is quality testing. Quality testing is where we're actually testing production data or actual data flowing into the pipelines. Does the actual data match our expectations? All right, so it's different from the first two. The first two, we're testing code changes. The last one here, quality testing, we're testing the data itself. Is the data meeting our expectations? So for example, in production, you have a pipeline that's running at 4 a.m. every single night. Now you're checking if the data you're pulling from source, when it lands in that raw area or the bronze area, does it match your expectations? We expect to have 1 million rows of data coming through every night. And we expect column A to have 0 nulls, and maybe let's say column B, we expect them to have values inside those columns that match these 5 different keys or 5 different values. It has to only have those 5 values. For example, like a column called state. You have only so many number of states. If any, we cannot have a state like, we have New South Wales, Victoria, we can have this one that's not in that list. We can check for those things as well, right? So that's what we call quality testing. And we can do it on different layers as well, bronze, silver, gold, we can do it on each. And that's what we mean by quality testing. We're checking if those things match expectations. How can we deduce what our expectations are? This is where we can use with a framework, for example, like Great Expectations, which is a Python framework. You can actually generate profiles of your data. So you can run that profile scanner. It goes ahead and runs it on your production data, generates a profile of your data. So for example, you've got 3 columns, like I mentioned, column A, column B, column C, and then it basically generates expectations for what those data should look like. Then when it comes to your next day's pipeline, your next day's ingestion, we're basically checking our, those incoming data against that profile. So does it match that profile that we set? And you can always customize your profiles as well. You can tweak it to relax the assumptions or make it stronger if you want to be more precise. You can do things like that as well. So when do we actually run this pipeline? This pipeline is actually going to be triggered every time our ingestion runs, right? We want to make sure data coming through matches our expectation. So every night 4 a.m., this is the pipeline that's going to run, right? So basically we add a step in our ingestion pipeline in say Airflow, we add a little step there, and that step there is basically checking against the profile, this data match. If it fails, if it doesn't match, we actually want the whole pipeline to fail. We want that to happen because we don't want to have incorrect data ending up in the reports. Once incorrect data gets a report, a user might make ill-informed decisions from that. So we want to fail the whole pipeline, throw an error. Okay, data engineers has to go and fix it. users don't get an updated report. The report will say updated as of 2 days ago. That's actually a good thing, right? They're not going to get the freshest data, but they're also not going to make wrong decisions from that data. So they will know there's a problem, and as data engineers, we'll try and fix it. All right, I'm going to pause there. Any questions on types of testing before we jump into specifics? All right, cool. Let's fast forward. Hopefully this stuff everyone's seen before as well. All right, so more specifically into unit testing and each one of those ones now. So looking at unit testing, what we're trying to do here with unit testing is build test cases on each function in our pipeline. Okay, for example, here we got a function to ingest silver layer. We have different functions here that help us get the data prepared for that silver layer. Okay, trigger, like I mentioned, you can do manual triggers or pull request trigger. Tools or frameworks, you can use your PyTest, which is the one I prefer, or you can use things like unit test as well, which is a built-in testing framework that comes shipped with Python. The next one is integration tests. Where do we do it? This here is a Airflow Databricks submit run operator. So basically this is sending, running a Databricks notebook. And that notebook is the thing that ingests bronze layer, silver, gold. And we want to run our integration tests on each one of those steps. Okay. Again, like before, we can do it manual, pull request, and we use the same tools as we would use on our unit tests. And the last type of testing is our quality testing. This is, again, like I mentioned, testing the data, whereas the first two is testing the code. So testing data, we again generate test cases, or in this case, like quality check cases and profiles for each one of these steps here. For example, this is a bronze profile, silver, and gold profile. And trigger could be manual or when the pipeline runs. Tools, Great Expectations is a very robust framework. It's one of probably, it's fairly new, but it's probably the most furthest ahead I've seen. It's a Python framework. Pretty heavyweight as well. It comes with a lot of features. If you want something lighter, there's another framework called SodaSQL. It's a more lightweight, but doesn't come with things like profiling and stores that data into a database, for example, for you automatically. All right, so let's talk about unit testing. That's what we're here to discuss today. So how do we unit test? So step one is to break your code down into testable functions. So on the left here is code that you might have written, and this is how all code normally starts off. You have a main function. Your main function here reads in a Spark data frame, then goes in, performs steps, cleaning steps on your data. So here, for example, I add a comment here, logic 1, 2, and 3. But if just imagine these are actually blocks of code, can be quite lengthy blocks of code to actually do various things. Then finally, we save our data somewhere, like push it out to a CSV file, for example. What we want to do for this first step is to convert those pieces of code into functions, right? So we want to turn them into functions so that now we can write unit tests on each of those functions. So we create a function for the first logic, function for second logic, function for third logic. Now we can write unit tests. So that's the step one. Step two is to choose a unit testing framework. So you've got options. Unit tests and PyTest, probably the most popular ones for Python. I go with PyTest because the syntax is more natural to write. For example, if I want to check if A equals to B, I just simply write assert A double equals to B, which is a very common thing you would write in Python, but if you're actually checking something is true, like you say if A equals B, here we're saying assert A equals B. Whereas unit test, you would write something like assert equal, which is just a little bit, not comfortable for me, but up to you. And then the other good feature as well with PyTest is that it supports the JUnit XML test output format. So the JUnit XML is it's a standard format for output for your test results, which can then be rendered nicely by your CI provider. So if you're using GitHub, GitHub has a way to render that test result in a very nice screen. Similarly with GitLab and Azure DevOps as well, you're going to get very nice looking screens to visualize your test results. Another nice feature about PyTest is you can actually execute Python unit tests as well. So it's like a superset that you can run different types of tests. All right, that's step two. So you've chosen your framework. I've gone with PyTest. Step three is to write your unit tests. So how do you write your unit tests? There's three parts to your unit tests. There's the arrange, act, and assert. Okay, so arrange is where you set up your dummy data, the data that you're trying to test with. You put that in the dummy data into a Spark data frame. Now you're ready to then act. So act is where you actually call that function you wrote. So pass your data frame into your function, receive the output, and lastly, we're going to assert. Assert is to check whether the transformation, the action that we performed matches our expectations. So the output doesn't match what we expect. So we run this little bit here, which says assert data frame equals, and we just check if it's true or false. That is typically it, normally speaking, if you're just doing any kind of standard testing. But because we're doing Databricks, there's one more additional step where we want to make sure that we are testing on the same environment where our code is going to be running on, okay, in production. So in production, we're going to be running our code on a Spark Databricks cluster. So we can actually set up a Spark locally on a machine. You can install Spark, or you can set up a Docker container and run Spark on that. But to be more precise, to be more exact, we want to actually test things on the Spark Databricks cluster. So how do we do that? That's where we use Databricks Connect. I'll show you how we can set it up later. Essentially, how it works is we've got our code on our machine. We can actually submit that code to run on a Spark cluster and receive the output back. So we can run our unit tests and all our stuff by sending stuff to Databricks. All right, and that's pretty much it. Those are the 4 steps you need to know if you want to do unit testing for Databricks. So I'll jump in now to a demo, and let's pray that this is going to work. And I'll show you how we can set things up. So first and foremost, all the examples I'm going to run through today can be found in my GitHub page. So let me just drop this here, my GitHub repo. I've got the steps all documented. So everything I'm going to run through now is documented. So if you want to follow along in your own time, perhaps at home, or if you're trying to do something for your business, have a reference to this docs here. It's very comprehensive. It has all the steps I'm about to run through. Okay. All right, so let's jump in. Cool, so I've got Visual Studio Code open, and that opens up to the repository I just showed you earlier. And in that repository, what we have here is a bunch of functions. If I expand the functions tab, we have cleaning utils, okay? So cleaning utils, for example, just picture with me for a second, you have a whole bunch of functions that you might write to assist you with your ETL pipelines, okay? For example, you want to be able to lowercase all column names. You don't have to repeat that every single time you're writing your ingestion notebooks, right? So you can write that into a function, and you can save that there. Similarly, we can add metadata, for example, right? This is a very common one. We want to store, for example, which task was the, if you have a task orchestrator, you might want to save your task ID as one of the columns, and you might want to save some timestamp for when this ETL job ran. So here, this is a function that adds some metadata columns to our data frame, okay? So these are the functions. We want to be able to test these functions and see if they work. So how do we do that? What we need to do is we create our PyTest, okay? So we're going to do the 4 steps we talked about. So first things first, we create our PyTest. So in functions, I'm going to create a new folder here called tests and create a new file. And this new file has to begin with the word test and cleaning utils is the name of my file. Okay? So PyTest will look for files with the word test next to it. Okay, so test cleaning utils, for example, or ends with test as well. So cleaning utils underscore test is perfectly fine. PyTest will detect that's a test file and will run it. So let's go ahead and write a test here. So define is the function, and we give the function a name that begins with test as well. Like before, we need to functions is wanted to be test, and we give this a name. Let's say I'm going to test this lowercase one. So I'm going to say test lowercase all column names. Now this thing here, we're going to start off with our assert, then we're going to look at act, and we're going to look at assemble, act, assert. So assemble, what we're going to do for that is to create. Let me just get my notes up. I'm going to create our dummy data. So our dummy data may look like something like this. This is our test data. It's a list, and it has 2 rows in there. Okay, row 1, here ID, first name, last name, age, and then row 2 is that second one. Okay. All right, so that's our data. Let's then save that data. This is currently in a Python list and dictionary, so we want to parse that through into a Spark data frame. So let's first go ahead and create a Spark session, like so. And it's highlighting here saying I've not imported my Spark session, so I'm going to run from PySpark.sql import row and Spark session. So I'm going to use those things shortly. Right, Spark session is there. Now with that Spark session configured, I can say spark.create data frame. And I want to basically convert that list and dictionary into a Spark data frame. And I need to map that into rows to achieve that. So this here is just a Lambda function that converts that data into a Spark data frame format. I can save the output into a new data frame, testdf. All right, so that's my example done. Now I can go ahead and act. So acting is just calling the function. So the function we've defined is in the other file here called cleaning utils, lowercase all column names. That accepts a data frame. And then it returns a data frame as well. So return df right here. Okay, in lowercase is all the column names. So let's go ahead and invoke that function. But first I need to import the function. So I'm going to say from, and I'm in this test folder. So I'm going to say just cleaning utils import star. So import all the functions inside of the cleaning utils module. All right, then I'm going to say, what's the name of this? This is lowercase all columns. So I'm going to say lowercase all columns, and that accepts a df equals to my test df. So pass in my data frame, receive an output df. Here we go. And act is done. So we've successfully retrieved the output, right? Now I want to assert, I want to check if the output data frame matches my data frame expectations. So to help me with that assertion, I'm going to use a little function here that comes with a pandas library. And that function is called pandas testing.assert frame equal. This is a built-in, someone actually wrote this for internal pandas testing, but actually people caught on and they realized, hey, we can actually use this to test other things as well. We can test our production data frames using the internal testing library. But that's really cool. So what we can do is we can pass in a data frame, 2 data frames to be precise, one on the left, one on the right, and we can check for different things. Here, for example, check D type, data types. So you can toggle that to be true or false, whether you want to perform that check or not. And lots of other checks you can do as well, okay? You can have a look at the docs here if you're interested. I'm going to pause there for a sec. Guru had a question. Do we have to write one testing notebook for each table? It's up to you. Depends how you want to structure your project. You can have a single function that tests a whole bunch of other things, or you can have one per notebook. Okay, it's up to you how you want to structure it, because your tests are going to live inside of functions anyways. So it's just how you want to break up those functions. That answers the question. Okay, so like I mentioned.
Sorry, John, you had another question there as well, just before you move on.
Okay, that's awesome. But what if the functions are written with Spark data frame specific functions and cannot be converted? That's fine. So what we are doing here is we're going to test our Spark data frame. Sorry, we're going to run the Spark functions on our Spark data frame. And then the resulting Spark data frame is what we'll convert to a pandas data frame. So you basically run all your Spark stuff. Once the Spark stuff's done, then we convert the data frame to pandas and use this assert, checking if the pandas data frame matches our expectations. Does that make sense? Okay, cool.
Jonathan, you also talked about the preference for PyTest because of the semantics of how you write it, assert, and then a statement. Is this moving away from that and instead using a, yeah, okay.
Yeah, so I'm not actually using any PyTest specifics here. So I mentioned PyTest is a superset. So PyTest can run your unit tests, can run its own native PyTest assertions, the assert, assert x equals to y stuff. And it can also run your pandas test stuff. So that's why I prefer PyTest. And then the last bit, which I'll show you shortly, is the JUnit stuff. So you can output your test results in a JUnit XML format. But yes, you're right. So I'm not, to this point, I haven't done any assert x equals y yet. So this is what you would write for a typical PyTest check. So far, because I'm working with data frames, I'm going to use this pandas library. Okay. All right, so let's write the assertion. So for me to write the assertion, I need to convert my Spark data frame into a pandas data frame. So I simply do this is a Spark data frame. Output df is due a Spark data frame dot to pandas to convert that into a pandas data frame. So this is a Spark step. Okay, so to your point, Steph, this here is due, everything is done in Spark. It's only when I want to do the assertion do I convert things into pandas to use that helper function, helper test function. Okay, let's save that one into a output df PD. Okay, let's just call it that. So that's my pandas, say as PD. Pandas data frame, okay, copy of the Spark data frame. Then I need some data to check my assertion. So I'm going to just quickly drop in some data here. So this is what you would normally write yourselves. You would say, yep, so I've got uppercase columns here. ID is uppercase. First name, the capital F and capital N are uppercase. So if my function works, then everything should be converted to lowercase, right? So this is what you would write, normally speaking, by hand. Okay, we have 2 rows of data, so we're just checking those columns match. It's highlighting PD as well, so I just need to import pandas as PD. There we go. Now we are ready to test. So I'm going to say pd.testing.assert frame equal. And the first data frame, I'm going to say, it doesn't matter which order you pass it, by the way, it can be vice versa. I'm going to say expected data frame first, and then our actual data frame output second. Then check exact equals to true. And there we are ready to run this test. Okay, I want to run it on my Databricks cluster. So what I'm going to do now is shift gears slightly. We're going to run this on our Databricks cluster. Anyone had a question?
You've got another one there.
Okay. Orderings of data frames from several workers can vary. Does pandas equate with that? Sorry, David, could you expand on that question, please? Hello, David, are you there? We'll come back to that. You might be on mute as well. Is your question about the distributed data frame? So Spark distributes a data frame across the nodes. I'm guessing that's what you mean. Yes. Okay. So yes, yeah, you're right. So when you convert a Spark data frame to pandas, it runs a job to actually bring all the data back from its nodes to the master node, to the driver node, and produce a single data frame, a pandas data frame. So you'll combine all of them to a single one. Okay. So we don't have to worry about data being in one node and the other.
And if it gets mixed up in its ordering in that process, I guess you could address that through perhaps sorting the data before running a test or something like that.
Yeah, 100%. So you can sort by ID, for example, and then run a test based on, you just order it accordingly here in your expected output. That's right. So commonly you will see something like sort being done before you assert. All right, so let's jump into actually running the tests now. As I mentioned, we want to test it on our Spark cluster. So let me just bring up my Databricks here for a sec for you guys to see. So this is my Databricks workspace. I have a cluster that's currently running. Okay, it's running on the Databricks 9.1 runtime engine. So jump in there. That's my cluster information. That's the URL there. And I want to go ahead and connect to that cluster. So from my notebook, I've got this library here called Databricks Connect 9.1.2 installed. This version has to match the version of your cluster that you're running. And there are a couple of different versions that are supported. Make sure you use the correct version if you're trying to connect. Then to connect, all I do is say databricks.connect configure. Okay, actually displays my token here. That's very bad, but I'll change my token right after this thing. So it's prompting me to enter in my host information. Okay, what host is your Databricks? And you can get all this information from this cluster URL here. So that's your host there. And then you have your organization, that's this bit here. And then you have the cluster ID, that's that bit there. So basically you're just copying contents from here into that config and then passing in your token as well. So you can generate your own user tokens and put that through. Okay, I'm going to cancel that. Okay. So once you've configured, you can actually test the connection by saying Databricks Connect Test. This is just going to run some generic tests that the authors of the Databricks Connect library has written. It's going to run a few different things. It's going to test the Scala command, for example. See what else it's doing here. It's going to do some Python tests and Spark SQL as well, maybe. Okay, testing Python. Okay, so we'll let it run, but basically it's just validating that you can connect to your Spark cluster and you're able to run all your tests. Okay, there you go. All right, so test works. So what it means is we are ready to run our notebooks. So to run our notebooks, we can go ahead, we can run our PyTest now. So we can say PyTest. And where do we run to run our test on? Which folder? We're going to test all the files inside functions. Anything that has a test file and any function with a test prefix or postfix. Okay, so PyTest functions. And it's detected, collected one item just means we detected one test, one function that matches this pattern. And it's inside of this test cleaning utils. It's running that test as we speak. All right, took about 10 seconds to run that, and the test passed. So our function here, lowercase all column names, has successfully converted these uppercase columns to lowercase, and it matches our expected output. Let's just show you one that fails. I'm going to purposefully change the expected to something that's incorrect, and let's run the test. Okay, so test ran, and we have an error. It's an assertion error. What's the error? So data frame column values are different. So 25% of the columns are actually different. And we can see that, yes, 1 out of the 4 columns that exist is wrong, right? So the ID is different, okay? So yeah, that is unit testing. Any questions up to this point from anybody? Feel free to go on mute if you have a question.
Jonathan, I have a question. So in this thing, is it possible for us to check the schema of a table in as a framework kind of a thing in one function, and we can check all the schemas, or we have to write schema for each and every table and check it?
Sorry, repeat that once more, please.
Like there is a change in the schema. Let's say there's a change in the schema. So all of a sudden we're getting integer instead of string or something like that. So are we going to handle that in the same scenario? Like do we have to write a function and do it, or do we have to separately write each of them?
Yeah, so what happens is, this is where I might have to double check this a little bit, but the Spark will convert to a pandas data frame, and the pandas data frame has its own data types. So with data types in pandas will differ slightly from data types in Spark, okay? But it tries its best to match. But let me show you a quick example here where if I look at 1 and 2, right, I've just changed them from integers to string. Everything else is the same, but the data types are different, all right? So let's give that a go, and it should fail as well with the wrong data types. Okay, so here it's failed as well, because on the left, which is our expected data frame, it's strings. So that's why we say object. Object just means string in the pandas world, and then int64 is what's on the right. So yes, it checks for data types as well.
Is it not possible to just output those records that are wrong, and then maybe like out of a million record we might see 1 or 2 which are wrong? How do we handle those kinds instead of failing?
That's actually not so much the point of unit testing. If you want to handle stuff like that, I think Steph is comments is probably right. It's like that's where you want to actually do it in production. If you have errors like that, you want to actually push those errors out into a quarantine area and then run a process to try and fix those things. So you can run an automated job, a notebook, whatever, to typically the kind of problems you expect, running on those before sending it back to the final table.
Okay, so you run this test cases first, and then you load the data once. Is it how it is? Okay.
Yeah, so this unit test here is more testing code changes. So if I were to change my actual function, so my functions, what I'm speaking of is like this lowercase function here. If I were to make some changes here, like do something silly like this, right? If I made this kind of code changes, this is the kind of things I want to check. Unit test would tell me if I've done something wrong.
All right.
Okay. What you're speaking of is more of production data. That's where we talk about great expectations type of testing, quality testing. Yeah. Cool. All right, so we've pretty much covered off how to run unit tests, and this is all running locally on my computer, sending it to the Databricks cluster. Now, the next part of the puzzle is how do we automate this, right? We don't want to run it locally every single time. In fact, we want to, encourage good DevOps practices. Every time someone creates a pull request in our team, we want to run the unit tests again to make sure that their code can works before we merge that into the master branch or the main branch or the production branch. Okay. So how do we automate a unit test? Turn on the laser pointer here. Here we go. So we need firstly choose a CI provider. So there are lots of CI providers out there that can run CI/CD pipelines. GitHub has GitHub Actions, GitLab has their GitLab pipelines, Azure DevOps has Azure DevOps pipelines, etc. So lots and lots of options there. Just choose one, whatever your organization goes with. Then you need to set up a agent or a runner. They're different names, but it just means a virtual machine somewhere that can execute the test for you automatically. So not on your machine, but on some kind of machine that's hosted on the cloud. So host it on any one of these three clouds. Then you can manage your dependencies. You can install some stuff like Python 3.8, comes out of the box, and then maybe Java as well if you need that. So you want to manage your dependencies using something like a Docker container, for example. Okay, lots of free Docker images out there, so you don't have to create your own Docker container. You can just say, yeah, this is the image I want to use for my pipeline. Okay, you don't have to code anything up yourself. Then we get to actually building the pipeline to run our tests. So we're going to write a pipeline using YAML, and we're going to set a trigger on that pipeline based on pull requests. Okay, and all tests must pass before we can merge, for example. All right, so let's look at an example of how we can do this as well. And bring up this little bit here. Okay, so we've got our tests all running. We can close out of these tests now. Now, let me just actually put in a few more. So I'm just going to copy some other tests I wrote. Okay, just dropped in some other tests in here. I dropped in 2 more tests. So we've done the lowercase one. I've dropped in another test now for uppercase and another test now for add metadata. So we're basically running 3 tests against the 3 functions that we wrote. So to set up a CI pipeline, I'm going to go with GitHub for this example. Again, depends on which CI provider you choose. For GitHub, we go in and we create a folder called .github/workflows. This is what GitHub looks for any CI pipelines it needs to run. So if you put anything in there, it's going to run those CI pipelines for you. I create a new folder in here, a new file in here called Databricks-CI. Okay, and then within that YAML, this is the definition. Okay, so the name is that you can give it whatever name you want on saying what would trigger this CI pipeline. Well, any push or pull request will trigger this at the moment. What jobs we want to run, give it a name. Where do we want to run this job on? What kind of image do we want to use? So this is the Docker image I was referring to earlier. This here is using an Ubuntu latest image from GitHub. So it comes pre-installed with some software on it, like Python and Java and a whole bunch of other things. So using that image. Steps is what is going to run on that virtual machine or the agent. It's going to firstly check out the code. So bring our code from the repo into the machine, check the Python version, install virtual environments because we're going to create a virtual environment to run a code in, and then activate the virtual environment. Then install any requirements. So I've got a whole bunch of requirements here that's needed to support my unit tests. A bunch of stuff here actually didn't quite matter, to be honest. I can recall some of it, but the main ones are Databricks Connect, Pandas, PyArrow as well as one of the useful ones. It helps us convert our Spark data frame into pandas. And I think the rest we probably don't need. PyTest we do need. Okay. Then we run our configure, like what we did locally. You saw me did this earlier, Databricks-Connect configure, and then you pass in your host name, your token, your cluster ID, your workspace. So this command here basically passes in those variables into the Databricks configure command. Once that's done, we run our unit test. So we say PyTest against the functions folder. And then this one additional flag here is to just say output the results as well in a JUnit format. Okay, so let me just run to quickly show you as well locally. JUnit XML equals to unit test results.xml. Okay, we found 3 tests this time locally. And once it's done, we'll see a new file appear. And the last step here, just to doctor it, is to publish the test results. So this XML here can be visually rendered. So we have a very nice looking screen that shows us our test results. All right, so JUnit test results file, this is what it looks like. This is just basically an XML file that contains the results of our tests. Okay. All right, so that's pretty much it. Let's go ahead and now run this pipeline. So I've defined this pipeline here. I can go back to my GitHub. Okay, we've got a code tab and we've got actions. So in GitHub, we've got this tab here called actions. Click into it. And we can run our Databricks CI pipeline. All right, let me just, I actually don't know how to trigger it from here. I usually just do a push. Let me just rerun all jobs. And this is kind of like running it, right? If you create a pull request or you do a push, this is what you'll see. So as we speak right now, this is actually queuing up to run this onto a virtual machine provided by GitHub, right? It's free. You get to use this service for free. Right now it's running. If you go into the job, you can see it's executing the steps that we wrote. Okay. Checking the Python version. You can visually see the output as well, Python 3.8. Oops. And then it's installing our dependencies from the requirements.txt file. Okay, should be done in a minute. Okay, whilst we're waiting for this to run, feel free to shout out if you've got questions as well. All right, Databricks configure, it's done. It's rendered whole configure input stuff. So it's connected now to a Databricks cluster and is running the PyTest on our Databricks cluster as we speak. Okay, 3 passed. And now we're publishing our test results. And so this is the beauty of the JUnit XML format. We go to click to this unit test results tab. We get to see a little bit pretty, a little bit not so, because GitHub doesn't come with the built-in one. It's actually a third-party tooling that we're using to visually see this. But GitLab probably looks a bit nicer. Azure DevOps looks a bit nicer. Yeah, so you can see 3 tests, 3 ticks. So all tests has passed. And you can see the raw output as well for what tests were run. All right, and that concludes my demo. So we've got to the end. Thanks for your patience. Any questions? So David has a question saying, can that be made to work for clusters within a VNet behind a VPN firewall? Yes, that can be done. So the question simply is, where is your agent hosted, right? Is the agent running on your virtual network? So for example, if I'm running locally as well, do I have a VPN that connects me to your network, for example, right? If I do, I can run my unit test locally on your Databricks clusters behind a firewall. Similarly, if the agent I'm running this on, the automated CI pipeline, if that's an agent in Azure or AWS that's within your VPC or your VNet, then yes, it can connect to your Databricks clusters. If it's not, we're going to get a, cannot connect to your cluster because not found. Okay, any other questions?